twice as large an area as 30 years ago. That meltwater does not in general make it to the edge of the ice sheet. It finds a low spot on the ice sheet, it burrows a hole in the ice sheet, goes to the base of the ice sheet and lubricates the base of the ice sheet so that the ice sheet then discharges these giant icebergs to the ocean at a faster rate as the melting increases. And although global warming also causes more snowfall in the winter because the air holds more water vapor as the atmosphere gets warmer, but we know that the common sense tells you that as the planet gets warmer, the ice sheets are probably going to get smaller. And that's confirmed now by the gravity satellite, which measures the gravitational field of the Earth with such a high precision that you can determine the mass of the Greenland ice sheet. And the ice sheet gets heavier in the winter, and then in the melt season it loses mass, but overall it's losing mass at a rate of more than 100 cubic kilometers per year. And West Antarctic ice sheet is also losing mass at almost as fast a rate. So if we want sea level to be stable, if we look at the history of the Earth, the prior interglacial periods, in order to have ice sheets comparable in size to Greenland and Antarctica, we would probably like CO2 to be of the order of 300 ppm. But in any case, 385, it's obviously unstable, and we're going to lose ice sheet mass. Another effect of global warming is to increase the overturning circulation, the rising motion in the tropics and the subsidence in the subtropics, which causes the subtropics to be dry. That overturning cell will expand as the planet gets warmer. And we observe empirically that it has already expanded by about 4 degrees of latitude. That's affecting the southern United States and the Mediterranean region and Australia and parts of Africa and South America. And so it's one of the reasons why the southwest is so dry recently, and Lake Mead and Lake Powell are only half full. And associated with that intensification of the subtropics is the increase in the forest fires, which have in the United States increased by about a factor of 4 over the last 30 years. One of the biggest effects of global warming is going to be on freshwater supplies. The glaciers all around the world are receding, the mountain glaciers. And these glaciers provide, as they melt during the summer and fall, they provide a large fraction of the water in some of the major rivers in the world. The rivers originating in the Himalayas and in the Rocky Mountains and in the Andes. So the Ganges River, for example, has 2/3 of its water in the late summer and fall coming from glaciers melting. Once these glaciers are gone, and at the rate they're receding, most of them will be gone in about 50 years. At that time, there will be hundreds of millions of people who depend upon these rivers for fresh water who will be in trouble if we continue on that path. The coral reefs are under stress. Coral reefs are the site for almost 1/3 of the species in the ocean. And they are under stress for several reasons, but 2 of the major reasons are the fact that the ocean surface temperature is increasing and the oceans are becoming more acid. As the oceans take up more CO2, they become more acid. And the animals that have carbonate shells or carbonate skeletons are threatened by this increasing acidification of the ocean. In fact, they can't live. Eventually, as it becomes more acid, it will dissolve the shells. So these animals can't live in that environment. So all of these things tell us that the amount of atmospheric CO2 that we need to aim for is no more than 350 parts per million, someplace probably in the range from 300 to 350. And we've already increased it from 280 to 385. Well, if we want to preserve a planet that looks like the one that we inherited from our ancestors, we're going to have to reduce CO2. That has become clear scientifically. And the problem now, and the reason it relates to things here, is that if you look at the fossil fuels, the oil we've already used, the purple portions of oil, gas, and coal are the fractions that we have used so far and already put the CO2 into the atmosphere. How much undiscovered reserves there are is somewhat uncertain in the case of each of the fossil fuels, but we've probably already approximately at peak oil. We've probably used about half of the oil. And we're going to use the amount, the easily available oil and gas we're going to use. It's owned by Russia and Saudi Arabia. We can't tell them not to sell their oil. So if you look at the size of these fossil fuel reservoirs, it becomes very clear the only way we can constrain the amount of CO2 in the atmosphere is to cut off the coal source by saying either we will leave the coal in the ground or we will burn it only at power plants that actually capture the CO2 and put it back in the ground. They can't promise that they will do it at some time in the future. If we did that, if we had a moratorium on any new coal-fired power plants and phased out the existing ones over the next 20 years by 2030, then CO2 would peak at about 400 parts per million if we are at, if we've used half of the oil now. And if the very optimistic estimates for how much undiscovered reserves are more accurate, then the peak CO2 would be closer to 425 parts per million. Well, we can, if the coal is phased out, we can get back to less than 350 ppm within several decades, and we can do it faster if we can get back within several decades if we improve our forestry and agricultural practices so that they soak up more CO2. If we reforest some of the regions that were deforested is the biggest thing that we could do. So it's technically feasible to get back to 350 ppm, but it requires a quick phase out of coal emissions. Globally, it would have to be done over the next 20 years, which probably means in the West you're going to have to do it somewhat faster than that because we are responsible for most of the excess CO2 in the atmosphere. The United States is responsible for more than 3 times more than the second country, which is China. Even though China's emissions have now passed ours on an annual basis now, but the CO2 stays in the atmosphere a long time. So we are responsible for more than 3 times what China is. So the problem is that fossil fuels now are priced the lowest. And in fact, that's partly because we're subsidizing them, and we are not charging them for the damages that they cause to health, let alone to climate. And unfortunately, it's hard to get governments to make fossil fuels pay their fair share. There's a lot more lobbying for the fossil fuel industry than for the future of our planet and the future generations. That's the basic conflict that we have. Energy departments and fossil fuel companies just take it as a God-given fact that we're going to burn all the fossil fuels. Well, unfortunately, we can't do that without creating a different planet. And as I've already mentioned, fossil fuel interests have a lot of influence in capitals worldwide. And unfortunately, young people and wildlife don't have nearly as much influence.